So my name is Jose, and I am going to talk about a control system for healthy, energy-efficient environments. So here's the outline of the talk, but for the sake of time, we just skip this and go straight to the motivation of the problem. So I think I'm here, perhaps in the room, there are many people like me that are allergic to pollen and dust mites, and will certainly benefit from having, indoor air with less allergens. And also, perhaps you live in an area with heavy traffic, or perhaps you have found yourself in a room working where there was poor ventilation, and then at some point you start to feel like tired and essentially less productive because of the stagnant air. I think from all these situations where we can see this poor air quality indoors, we can see the importance of this of having good air quality conditions. Um, of course, I mean, these affect our health and our comfort and ultimately our quality of life. And it's interesting because I mean, perhaps we will think that outdoor air is more polluted than indoors, but actually, studies have shown that indoor air can be like 2 to 5 times more polluted than outdoors. And essentially, there are many reasons for this. For example, airtight buildings. This happens with modern constructions. For example, we can have also chemicals coming from the materials of our houses, insulators, for example. Um, Daily activities, when we cook, we use chemical products, sprays, etc. And also, of course, outdoor pollutants and allergens. Um, so how can we deal with this issue? I think we can maybe a good idea to design a indoor air quality manager, like a smart system that can monitor the air quality in indoors, and essentially then uh, prescribe actions to do to keep air in healthy levels and do it in a smart way. Um, so what these smart system will do is to track the levels of all these quantities that are used to uh, measure the quality of the air. For example, carbon dioxide, particle matter, volatile organic compound. For example, as what Jose just mentioned, particle matter 2.5, for example, is used to measure, for example, particles that are inside hot pollutants, that and also pollen as well. Certain types of pollens. Let's see. So the idea is to have like a system that measures the data from sensors distributed around the house, and okay, and then of course, I mean, activates ventilators and air purifiers according to the state of the air in the house. Um, so, and the idea is to do like is to have like a proactive uh, control, for the air. Um, Current systems, that are commercial, essentially they are mostly reactive. So essentially that means that they act when an event happened. But it will be more beneficial. We will have a better comfort, and also we can optimize for energy and cost if we have like a proactive solution, which essentially acts, before an event occurs. And here is, where machine learning can be very useful because it helps us to have these proactive capabilities. Um, for example, ways in which the system can act proactively. So the system um, can track the weather conditions, outdoor weather conditions, and have this information, and then essentially can decide to um, when it knows that is a day with high pollen levels, it can and there is a need to bring fresh air in the house, so it can already start the purifier before the ventilation happens. um, for example, when we are cooking also, the um, so the smart system can activate control fans and purifier in a way that based on the information that it has from past activity of cooking, and also the physics of these processes, because it also can learn the physics. Um, So like overall, our vision is to have a smart system that can know the indoor conditions, know the outdoor weather, knows the electricity prices as well, understand the physics of the household activities, and maintains healthy air by controlling ventilators and air purifiers. And of course, I'm minimizing the energy cost. So, I mean, here's the architecture of our system, where essentially it can be uh, essentially divided in these 4 blocks. So we have a temporal feature engineer, activity classifier, proactive forecaster, and a control logic. And so essentially, the temporal feature engineer is the block that will take the incoming data from sensors, and then it will transform the data so that it can be, probably used by our activity classifier and also the proactive forecaster. So the activity classifier will essentially determine what is the activity that is going on inside the house based on physical footprints of those events. Um, Essentially based on quantities that are coming from the feature engineer. Um, so then the proactive forecaster will use that information of what activity is happening and also information of what is the current state of the air, and will produce a forecast of what will be the pollution that will be produced, for example, in 10 minutes or 30 minutes after the activity started. So with this information, the control logic can actually determine what is the most efficient strategy for manipulating ventilators and purifiers. Um, So just one slide of the data science of the part of the data science. So I've used a data set from an open source repository. It's called Dalton, which gave me the information about all the data from sensors and activity annotations. The activity classifier was implemented with XGBoost, and the forecaster with Hurdle Light GBM multi-output regressor. Let me just show you a simulation scenario. This is a case in which we have a house with we have a kitchen, a dining room, primary bedroom, secondary bedroom, and living room, and there are sensor devices, in all these rooms. So we have also a fan in the kitchen, a fan in the bedroom, and also in the dining room, and then we have purifiers in the living room and also in the bedroom. And here's just a result, of running this simulation, and I generated synthetic data, and this is just the result of how the mechanical ventilation and the purifiers were sort of modulated by or regulated by the controller. For example, here we can see from 7 between 7 and let's say that 10, there was an activity, a cooking activity. Somebody was cooking breakfast, and then we can see, for example, in the red curve, the kitchen exhaust fan, and it was essentially the speed was regulated according to what the level of pollutants in the kitchen. Similarly, the purifiers were activated accordingly as well. Um, okay, in summary, so essentially we developed like a smart system that combines machine learning for activity classification and also for proactive forecasting, act before air quality degrades. Um, this essentially maintains optimal indoor air quality, and to protect health. It will improve also the sleep quality and cognitive performance, and it also is aware of the costs that are happening. So essentially, in such a way to derive strategies that can also help to optimize energy use and reduce costs as well. Future directions, perhaps exploring the use of LSTM, this neural network. Uh, Perhaps evaluate the use of reinforcement learning in the optimal strategy determination. Um, and also building an app to introduce personalized user preferences in the system. to optimize health, comfort, and energy costs, for the person, and also deploy this, solution in an edge device. Thank you very much for your attention.